So in question 5, we have the opportunity to use some of our skills regarding the Cartesian coordinate plane and geometry. The first one asks us to find the equation of a line that goes through these 2 points. The points there are A and B. Later, we're going to be asked to find the length of the line segment that connects A and B, and then finally find the midpoint of that segment AB. So they're all regarding these 2 points. So first thing we're going to do is find the equation of the line that goes through those 2 points. And in order to do that, we're going to calculate the slope. I can tell looking at it that the slope is going to be negative, but let's go ahead and find out exactly what it is. I guess I'm going to take 1 and subtract 8 for my change in y. So you can see I'm starting at this point and going to that one. So for my denominator, I'm going to take 10 and I'm going to subtract negative 4. Very important that I see that, right? It's the same pattern. It's the 1 minus 8 and the 10 minus, and then you can see over here the case it's a negative 4. So when I look at that, in my numerator, I've got 1 minus 8 is negative 7, and in my denominator, I've got the number positive 14. So my slope ends up being negative 7/14, and that reduces to negative 1/2. So the slope of my line is negative 1/2. So this whole pattern is down 1 over 2, down 1 over 2, etc. Now I need to calculate my y-intercept, and I'll just arbitrarily pick one of my 2 points. I'll pick this particular point. So if I write y equals mx plus b, I know an x and a y from that point, right? For this particular point, I've got a y value and I've got an x value. So I'm just going to plug in my y value, which is 1, and that equals my slope of negative 1/2 times my x value of 10, and then plus b. 1/2, negative 1/2 times 10 is negative 5 plus b, and that's what 1 equals. So if I add 5 to both sides, I end up getting that b, my y-intercept, is the number 6. So somewhere over here at positive 6 is where it's going to cross. So the equation of this line, I'm ready. I've got the slope and the y-intercept, so I can write the equation of this line for part A would be y equals negative 1/2 times x, and then plus 6. Negative 1/2 x plus 6. Next, find the length of that segment. So I guess I'll look at the same diagram. Any 2 points on the Cartesian coordinate plane can be reduced to you know, a right triangle like this by looking at the run and the rise. So you can see that this went down several units, and then I've got a run that's going over quite a few units, and I'm asked to find out the length of the distance between those. So I'm focusing on this right triangle at this point. The difference in my y values, I can see y is going from an 8 to a 1, so this is a difference of 7 units. So one side of that right triangle is a 7, and the other one's going from negative 4 to positive 10. This is 14. So this looks a lot like it does when I'm looking at the slope triangle, except the lengths of these are they're positive, right? They're lengths of triangle sides now, so I'm not writing this as a down and over. I'm just writing as positive 7 and 14. So I know that the distance between those two would be given by the Pythagorean theorem, and I can say, for example, that the distance between AB, right, that's the length of the segment AB. By the way, notation, if I want to talk about this is segment AB, and then just AB by itself is the length of the segment. So this is length of segment AB is going to equal the square root of 7 squared plus 14 squared. I'm going to bring this over. I know the 7 squared is 49. 14 squared, I don't know why that's drawing a blank. I imagine I should know that. And when I see it, oh yeah, of course it's 196. So I've got 49 plus 196, and I'm going to just go ahead and add to that 7 squared. Why are you writing it like that? I'm just verifying. So I should get 245. And the square root of 245, I could do this. Let's see, I'll take the square root of 245. And that's going to give me a lovely distance of about 15 point, I guess I'll round it to 15.7. So the distance, the length of segment AB, is approximately 15.7 units. So, all right, so we've now got the equation of the line, we've got the length of the segment AB. Final thing here is to find the midpoint. So somewhere on this line segment, there's a point that's in the middle. And a couple different ways you can do it. I mean, I know how long the segment should be, and there's a lot of different ways I can do it, but I like to just focus in on the endpoints and find the average of the endpoints. So if you look at this, my endpoints were at they were at -4, 8, and the other endpoint was at 10, 1. So I'm going to first of all look at the basically the average of my x values. So I'm going to look at the two different x values. I'm going to add them. So I'm going to add a -4 plus a 10. That's them added together. And then I'm going to divide that by 2. So when I do that, I get a value of 6/2, which is 3. So the value the value of my x coordinate is 3, and I'll do something similar for the y coordinates. For y's, I'm going to take 8 and add 1, and I'm going to divide that by 2. So that's going to give me 9/2, which is 4.5. So when I look at this, I've got x is 3, y is 4.5. And this is the location of the midpoint. Now, I go back up and I look at this, and yeah, it totally looks like it. If this is 10, 1, 2, 3, and then about up 4.5. So totally reasonable that this is, should be a little bit lower if that's the 6. But this is the location 3, and then 4.5. All right, so 3 different things there, right? Given 2 points, we found the equation of the line that goes through those points. We are able to figure out how long the segment is that joins those points, and we're able to find out the middle location, the midpoint of those 2 points. So that's the end of question number 5.